Question 22. Explain why DNA replication is slightly slower in the lagging strand of DNA than in the leading strand. DNA replication is slower on the lagging strand than on the leading strand because upon initiation, the leading strand has an RNA primer added, so the synthesis of the new DNA can be continuous in the direction of the replication fork and only needs to be ligated when it encounters another replication fork. This is because replication is proceeding in a 5' to 3' direction, the direction in which DNA polymerase III can synthesize a new DNA strand, period. On the lagging strand, many RNA primers need to be added to keep the process continuing. Since many RNA need to be attached to the parent strand, the formation of short Okazaki fragments occurs opposite to the replication fork. This is opposite to the direction of DNA polymerase III's ability to work in a 5' to 3' direction. The additional step of removing the primers has to be completed by DNA polymerase I, in addition to replacing the appropriate nucleotides. Lastly, DNA ligase must be joined DNA ligase must then join the Ozaki fragments, all of which takes additional time. Question 25. Compare this. Oh, no, we're going to skip that. Okay, question 26. Summarize the different steps involved in all stages of translation in a chart and use diagrams. So, initiation. mRNA binds to the mRNA binding site on the small subunit of a ribosome. The ribosome recognizes and binds to the 5' cap on the mRNA. The initiator, met-tRNA, carrying amino acid, methionine, binds to the start codon, AUG, on the mRNA. The initiator, and then after, the large subunit joins and creates an active ribosome. Elongation. Elongation consists of 3 steps that are repeated. 1. Addition of AA-tRNA to A site, complementary to next codon on mRNA. 2. Formation of a peptide bond between amino acids, polypeptide passed to tRNA in A site. Step 3. Ribosome complex shifts along the mRNA by 1 codon in the 5' to 3' direction. At the start of elongation, the initiator tRNA is in the P site and the E and A sites are empty. An aminoacyl tRNA binds to the codon in the A site via complementary base pairing between anticodon and codon. Termination. The ribosome will eventually reach a stop codon on the mRNA. The 3 stop codons are UGA, UAG, and UAA. Since these codons do not code for an amino acid, there is no corresponding tRNAs.